Hey everyone, Mr. Kaczynski here. Simplifying radical expressions involving fractions today, part of IXL's Algebra 1, section EE. I picked out a lot of examples here. I had a tough time narrowing it down, so let's get right after it. All right, basic gist of it here is if you have the square root of a fraction, it's the same as the square root of the numerator over the square root of the denominator. So nothing big here. Square root of 25 is 5. Square root of 4 is 2. 5 halves times 5 halves is 25 fourths. That's why the square root of 25 fourths is 5 halves. All right, same thing here with one little minor difference is that the numerator is not a perfect square, and it also can't be simplified though, but the denominator can be. It's a perfect square. Square root of 9 is 3. So we're just going to leave it like this. That's a simplified radical. Because the numerator or the denominator doesn't have a square root sign in it, and the numerator, the part that's inside the square root, doesn't have any perfect square factors. Let's move on. Like I said, I got a bunch of them. This one, the fraction can be simplified, okay? So let's simplify that fraction. Let's make it 5/9. And then the square root of 5 is the square root of 5, and the square root of 9 is 3. All right, so we simplified the fraction first, then took the square root of the numerator and denominator. All right, finally we get to one where the numerator does have a perfect square factor, 25. 25 times 3 is 75, and 25 is a perfect square. Meanwhile, on the bottom, the square root of 4 is 2. All right, so the square root of 25 is 5, and the square root of 3 is irrational. And the numerator, we already simplified, it's 2, or the denominator, excuse me. So 5 times the square root of 3 over 2, and that's it. That's our simplified radical. It's a simplified fraction, does not have a radical in the denominator, and the radical that's in the numerator does not have any perfect square factors. In fact, 3 is a prime number. This one is a little different because the denominator for the first time is not a perfect square. So we have to do something that's called rationalizing the denominator. If we multiply the square root of 3 by the square root of 3, we'll get the square root of 9, which is then a perfect square. But whatever you do to the denominator, you also have to do to the numerator. So again, on the bottom, square root of 3 times square root of 3 is square root of 9, which is 3. And then at the top, the square root of 2 times the square root of 3 is the square root of 6. And I don't think IXL introduces multiplying radicals until the next skill. So that's a little weird that you have to know how to rationalize the denominator. But that's how you do it, and we'll do it a few more times here. These get a little tougher here. All right, 6/10. That can be simplified. So the first thing I'm going to do is simplify 6/10. I'm going to make it the square root of 3/5. Now, in the denominator, I've got a number that's not a perfect square, so I'm going to use that idea of rationalizing the denominator. I'm going to multiply by the square root of 5 over the square root of 5, because on the denominator, square root of 5 times square root of 5 is the square root of 25, also known as 5, and in the numerator, square root of 3 times square root of 5 is 15. 15 doesn't have any perfect square factors, so this is simplified. Square root of 15 over 5. This one's, it looks bad, but it's really not that big a deal because the denominator is a perfect square. So let's make it square root of 7 on top, which cannot be simplified because 7 is a prime number. It doesn't have any perfect square factors. In the denominator, the square root of 9 is 3, and the square root of z to the 10th is z to the 5th. Z to the 5th times z to the 5th is z to the 10th because 5 plus 5 is 10. So square root of 7 over 3z to the 5th. Let's keep going. I know I'm going fast, but please rewind if you see something that you need another look at. All right, again, denominator is a perfect square. I can't simplify inside the fraction. In the numerator, though, I'm going to look at that c to the 5th as c to the 4th times c. That's still c to the 5th, and now c to the 4th is a perfect square. Denominator square root of 49 is 7. All right, so we've got the square root of c to the 4th is c squared. inside the square root sign in the numerator, we still have 2 and c over 7, and that is simplified. C squared times the square root of 2c over 7. I know it's ugly, but that doesn't make it not simplified. All right, square root of 30 over the square root of 7 q to the 6. Okay, square root of 30 cannot be simplified. It doesn't have any perfect square factors. On the bottom, though, let's take the square root of that q to the 6. That would be q to the 3rd, and we still have the square root of 7. Now we got to get rid of that square root of 7, so we go back to that idea of called rationalizing the denominator. If we multiply by square root of 7 over square root of 7, that's the square root of 1. I'm sorry, that's 1, which doesn't change the value of the whole fraction. Okay, so square root of 30 times square root of 7 is square root of 210, which does not have any perfect square factors. You might have to look and see if there are. And then on the bottom, square root of 7 times square root of 7 is 7, and 7 times q cubed is 7q cubed. So square root of 210 over 7q cubed. We got rid of the radical in the denominator. The radical that's in the numerator does not have any perfect square factors. I've got 2 more examples for you. Hang with me. All right, now this one, 49 over 63, that can be simplified. So that's the place I'm going to start, okay? 49 and 63 both have a common factor of 7. So some people might want to take the square root of that 49, but I'm not going to do that. I'm going to always simplify it inside the radical. I say always, but most of the time. Let's put it that way. So 49 divided by 7 is 7. So 7n to the 4th. And then in the denominator, 63 divided by 7 is 9. 9n to the 8th. And trust me, we just made things a lot easier because now we do have a perfect square on the bottom instead of that 63. All right, so all we did was simplify the fraction. So on the top, square root of n to the 4th is n squared. And then the square root of 7 is irrational, so we'll just leave it as the square root of 7, over the square root of 9, which is 3, and the square root of m to the 8th, which is m to the 4th. And that's our answer, n squared times the square root of 7 over 3m to the 4th. I got one more. It's a bit of a doozy. All right. First of all, I do see c's in the numerator and the denominator of this expression. That can be simplified. 25/18 can't be simplified. So here's how I'm going to write this. The square root of 25 c to the 7th d to the 4th over 18. All right, so 8 minus the 1 here gave us c to the 7th. All right, what next? How about we make this on the numerator? 25 is a perfect square. C to the 7th isn't, so we'll break it into c to the 6th times c. I talked about that in the last video. And then d to the 4th is a perfect square, all over the square root of 9 times 2, which is still 18, but 9 is a perfect square. All right, here we go. Square root of 25, 5. Square root of c to the 6th, c cubed. Square root of d to the 4th, d squared. And then we still have the square root of c up there in the numerator, all over, I'm running out of colors here, how about square root of 9, which is 3, times the square root of 2. Now one thing I have to do here is multiply by square root of 2 over square root of 2 to rationalize the denominator. I got to get rid of that square root of 2. And when I do square root of 2 times square root of 2, I'll get square root of 4, which is 2. All right, so we're about done here. We're going to call this 5c cubed d squared times the square root of 2c, square root of 2 times square root of c, square root of 2c, all over square root of 2 times square root of 2 is 4, and 4 times 3 is 12. Woo! That doesn't look simplified, but technically it is because it doesn't have a fraction in the radical like we did here. It doesn't have a radical in the denominator because we rationalized it. And the expression inside the radical in the numerator doesn't have any perfect square factors. 5c cubed d squared times the square root of 2c all over 12. All right, so that's simplifying radical expressions involving fractions. Let me know how it goes.